Today I'd like to show you some of the most common provisioning questions I get with regard to Satellite. So I've prepared a few demos for us to go over today. The three areas that I want to cover today are PXE-less Provisioning, showing you an example of how to do a cloud-init image-based provisioning build using Satellite and Red Hat virtualization. Secondly, I'd like to show you some of the options in Satellite with respect to using Ansible in the provisioning process. And lastly, I'd like to show you a provisioning example using solely Ansible Tower for the build process. Let's get started. So for some of the options that we're going to go through today, I'll cover some of the prerequisites that need to be done beforehand for this process to work, as well as I'll cover some basics on what else is being used in this provisioning process that should apply to all of the provisioning processes that you use within Satellite. So one of the first things we need to do to cover this first PXE-less provisioning example is to download a QCOW2 image from the Red Hat customer portal and upload this into Red Hat virtualization, of which we make a template from. So to show you an example of this, I've got a QCOW image uploaded into my RHEV disk store, and I've got a RHEL 8.2 VM template created out of this. So what this does is it gives us a basic structure in RHEV to provision into that's repeatable, that Satellite will use to create a virtual machine. The other thing that we'll need set up prior to doing this image build is we'll need to have RHEV added as a compute resource within Satellite with images and profiles defined. So I've got RHEV added in here as a compute resource. Basically, this is a pointer to the RHEV API, which Satellite will call at VM creation time. We've also got set up the image created in Red Hat virtualization that Satellite will use to build the new VMs, as well as some basic t-shirt sizes set up for the virtual machine sizes that we'll be creating. Lastly, one of the things that we'll need to set up is the cloud-init template that will get used in this process. Now, because this is a PXE-less provisioning method, we're not going to be using a kickstart file or a partition table file within Satellite. That is going to be done for us beforehand by this QCOW2 image. Basically, it's going to replace the copying of the operating system to the disk in the PXE boot process. That's already going to be completed by using the QCOW2 image. But what we're going to do is we're going to use the cloud-init template to act as the post-provisioning script on the QCOW image once it gets instantiated and up on the network. So moving into Satellite, you can go to Host and Provisioning Templates, and you'll see that I have cloned and created a new cloud-init file that will get used in this PXE-less provisioning method. And if I open this cloud-init file, what we'll see here is a basic cloud config structure to configure things like the host name, adding a couple users, and then using the run CMD facility to run a few scripts that will register the host with my activation key to Satellite, and then it'll do some basics at the end, such as telling Satellite that the server has now been built, and then it'll reboot the server. Then lastly, as part of this image-based provisioning process, we're going to be reusing the existing activation keys, content views, lifecycle environments, and the virt.hu setup and operating systems already set up in Satellite. These should be usable across the rest of your Satellite provisioning processes, regardless of the provisioning method. So with that, let's get started. I'll go to Hosts and create host. I'll give this a host name, pick my location. I'm going to pick the compute resource RHEV here. I'll give it a medium t-shirt size. We're going to configure this to the prod lifecycle environment. It's going to be a RHEL 8 host. And we're going to pull content from the content view RHEL 8 that's on Satellite. Now here I can add an Ansible role, but I'm not going to do that with this particular example. The virtual machine template that we use here is the one created in Rev as per before. It's already got a 10 gigabyte disk assigned to it that's already built that we'll be leveraging. So here I'll go and pick my operating system. This is going to be a Red Hat 8.2 build. We're going to use an image-based provisioning process here again. So this populates the RHEL 8.2 image that already exists for us to use. I'm not going to set a root password because that's already defined in the image. And then here I click Resolve and it shows me, based on all the selections that I've made, the templates that are going to get used in this provisioning process. And here we see it's using the cloud-init script that I'd shown and created beforehand. And lastly, I'm going to go into interfaces and make sure the domain gets properly set for this host. We're going to use DHCP to get this IP address for this host, and then I'll click Submit and start the provisioning process. So as we click Submit, Satellite is going to call the Rev API to create this virtual machine. So if we go over to Rev and list the virtual machines, we should see the new virtual machine container within Rev being spun up here. So what this is doing again is reusing the VM template that we've created based on the RHEL 8.2 disk image that we've downloaded from the portal. And then this is going to create the VM container using our t-shirt size and boot up the VM. So as I click on this VM and hit the console, we see that this is already booted up for us. So that's great. The image-based provisioning process is very quick as we skip the steps necessary from a PXE build in copying all of the operating system files, etc., to the disk. That is already done for us in the image-based provisioning process. So now as I go back to Satellite, I see the status screen is moved to pending installation, and we've created this host within Satellite, and the status is okay. So if I click back on all hosts, we see that this is now listed at the bottom, and we're going to wait for the rest of the cloud-init script to provision this host and change this from pending installation to completed. Now that we've waited a few minutes for that host build to complete, we click back on the host name and we see that the build status has moved from pending installation to installed now that the last bit of the cloud-init script has ran. We also see that the subscription has been applied to the host with the activation key, and we've got some applicable errata outstanding for the host, giving us a error status until we apply those. Now moving into Red Hat virtualization, we see the VM has been created and populated, and as I do a test login using the cloud-init user that we had set up in the cloud-init script, I'm able to SSH to our host. Now that our host has been created and we verified that we can get to it, I'll leave you with a example how-to article link that goes over the process in more technical detail of how to set this up. This basically runs you through what I've just shown you with Satellite and Red Hat virtualization. For the second use case and demo that I wanted to cover today, I'm going to show you some of the options Satellite has to use Ansible in the provisioning process. The first one I'm going to show you is just a couple of the template files that can be used in a provisioning process with Satellite. So the first one, I use a generic kickstart file, and Satellite has a concept of snippets. Basically what those are is it is a reference to another piece of code or script that can be inserted into a kickstart file or another provisioning file used in the provisioning process. So for example here, you can see that I've got a snippet set up to insert the root password hash, as well as a snippet set up to inherit the RHEL 8 partitioning table that I like. So what this allows me to do is have many Kickstart files created and to reuse the snippets that are common amongst builds, or if you want to use a snippet as a way to more modularly address configuration in your Kickstart files. So for example here, I've got it referencing the root password hash, and I've got that in a separate file. So if I wanted to reuse that would make it very easy for me to change the root password somewhere else and have that inherited in this Kickstart file. Same with the provisioning snippet. So remembering the name of this snippet file, you can see the syntax here. Then if I go into partition tables, you'll see that exactly same named partition table file where it contains this information in it. So essentially what that snippet does in Satellite is it inserts this piece, this snippet, into that original Kickstart file. Now, the way we could use Ansible in the provisioning process is to reference an Ansible playbook in one of those snippets, for example. Or if we wanted to do something more sophisticated, we could use Ansible Tower and include it in the provisioning process by using what we call a callback script. And so what this looks like in its very basic form is basically a curl that reaches out to the Ansible Tower API and a corresponding job template or provisioning playbook where Satellite boots this host that we are provisioning. Once this host comes up on the network, it's this callback script that reaches out to Ansible Tower and says provision me using a predefined host configuration key and a URL to the Ansible playbook or job that we want to run on this host. And this snippet is what will cause that execution to happen on the provisioned client. Now, something else we can do with Satellite with respect to using Ansible either in the provisioning process or in a more ad hoc way is we can use Ansible as a remote execution piece to run automation across the many hosts that we may have. And I'll show you what that looks like. So I've got 4 hosts here below that I've selected, and I want to run an action on them, and I will go schedule remote job. So here it gives me some options that I can use to run automation or run remote executable commands, and one of them is Ansible playbooks or an Ansible command. So I'll select an Ansible command, and I'll suggest that it runs the hostname command on these hosts. So now what this is going to do is this tells Satellite to go and reach out to those 4 hosts with an Ansible module of command and to run hostname across these 4 hosts and give us the result. There's some extra parameters in that menu that I didn't show you, and they show up on the side here. One of them is the user that we're using to authenticate with Ansible out to those hosts, and in this case it's the root user. And we see that these 4 hosts all came back successful on this job run, and if I click on the host name, it gives me the output as we would have it on our workstation console had we run the Ansible utility directly. So this is a good example of how we can run ad hoc commands across our Satellite inventory and run some automation out in our environment. Now I've showed you how to run an ad hoc command in Satellite using Ansible. It's the exact same process to use a playbook instead of a command. So lastly, I'll show how we can run Ansible roles on our hosts in Satellite. So first off, I go into host groups, and you can see I've got a few groups here. One of the groups that I've got is virtual hosts, and I can apply an Ansible role to a host group. Now what this will do is it will allow that Ansible role to be applied across a grouping of hosts to make it easier for me to automate the environment and ensure that the same configuration is set across multiple hosts. So in this host group here, you can see that I've got the Red Hat Insights client Ansible role assigned to this host group. And this is what allows that host membership to inherit this Ansible role. So if I go back to my hosts menu, And again, I've got these 4 hosts selected. I can select an action and say, run all the Ansible roles on these hosts that apply. Now what this will do is it will go out and it will apply all of the roles that we have set in this host group, and it'll run all of them sequentially. So we'll give this a few minutes to run. As this is running, what we can do is we can click on the host here to get the raw output of what the Ansible task is doing right at the moment. So as we scroll down, we can see that the role is going through all the different tasks that are within that role. So for example here, we can see that it's installing the Insights client, or ensuring that it is, setting its configuration, registering it, etc. So as this host goes through this role process, all of the tasks that are inherent in that role will get applied to the host. And we can see that it's finished successfully at the bottom. Now going back to our job action screen where we ran the Ansible role, we can see that the role has been successfully applied to all of our hosts. For the last demo that I'd like to go over with you today is an Ansible Tower provisioning process using solely Ansible Tower and no involvement at all from Satellite. As with the other use cases, there's a couple prerequisites that we'll need to have set up prior in order to do this build. In Ansible Tower, some of the first things we'll need is our credential details for a few different sources. To provision into Azure, of course, we'll need to set up our Azure subscription ID and account details. We can save these in Ansible Tower for usage. Similarly, we'll need a GitHub account to pull the playbook from. And this will be set up in Ansible Tower here as well in the credentials. And lastly, we'll need a machine credential in order to be able to log into the host once it's been provisioned. Secondly, we'll need the actual playbook created that will go out and create the VM in Azure. Now I've got an example created here that you are welcome to use, borrow, and change as you see fit. And basically what this is a series of modules that will go out and create the appropriate resources in an Azure account that the VM will use for creation. I do reference the golden image that I've also built and uploaded into Azure as a prerequisite step, but you are welcome to use the marketplace image or another bring your own subscription image in this process as well. Just change the name there and that will be fine. So to show you what this provisioning process looks from an Ansible Tower perspective, I log into Ansible Tower and I go to job templates at the side, and here we'll see all of the job templates that I've got created and loaded into my system. And the one we'll be using today is the one here called Provision Web App Test Infrastructure. So what this is it's going out into Azure and using my Azure subscription details and using this playbook that I've got in the GitHub account. It's going to go out there and create that instance for us. And then it's also going to dynamically ingest the Azure inventory into Ansible Tower so that we can take further action on that host. So to see this process in action, let's kick it off. So I'll start the job using the launch icon here. And here we'll get a summary of the job and the actions and the job details at the left-hand side, as well as output of the job as it's running live on the right-hand side here. So we see the status of the job is changed to running. It's got some basic information here about the job, what inventory is being used, who ran it, the playbooks that it's pulling from and the exact playbook, and also the subscription details, or the credential details that it's using for this job. On the right hand side here we see the playbook in action. So I've done some basic validation to make sure the VM details have been populated. Do we have our Azure credentials set? And now it's going out and creating the resources in the Azure account. I'll give this a few minutes to go through its paces. So looking at the Azure portal, we start to see some resources be created from the playbook. We'll see everything get populated here in the resource group called RHEL Tower CI/CD as Ansible Tower goes through and creates the rest of these resources. We'll give this a few minutes for it to complete. So after a couple of minutes, we see that the playbook has completed and our application VM has been created. So now if I go back into my Azure account and refresh the portal, I will see the virtual machine and all its resources created and available for use. From here, if we wanted to take any additional steps, we could put them in a provisioning callback into Ansible Tower for any extra provisioning steps that we'd want to have occur on this virtual machine.